Hello everybody. Today we're going to be learning about dividing decimals by whole numbers. I'd like you to take a look at the top of your flip chart there and see 75 hundredths divided by 3. I'm going to be teaching you 3 different ways that you can learn this today. One is a model, one is using a real-world situation, and one is using the algorithm. If algorithm is confusing to you, I mean when we add, subtract, multiply, or divide something, that's the algorithm. So let's see here. Look at this representation. This is 75 hundredths. What I'd like you to do right now is go ahead and divide it into 3 equal parts. Pause the video and come back to check your work. And they're going to pause. Alright, let's see if you did the same thing. I took this and, let me move this out of the way, and I separated into 3 even parts. And I found that each part was 25 hundredths. So I used the model to answer this problem. Now let's look at a real-world situation. If you have 75 cents and you equally split your money among 3 of your friends, how much money does each person receive from you? And once again, you can use that tool of using the model to see the 3 different 25 hundredths, or relating it to a real-world situation, and you can also use the algorithm, which we're going to be moving on to. So this is how you've probably learned division before, using long division. However, sometimes we get it confused when we use the language along with it. For example, these 2 algorithmic representations are the same, even though they look a little different. They are 75 hundredths divided by 3. You say it the same way for each. Sometimes we can get confused and we would write it like this, 75 hundredths divided by 3. But really, it's the 75 hundredths that we're dividing. So this is incorrect. Knowing that, let's move on to the algorithm. So we're going to just go through the regular process of long division. And what I want you to do for right now is not recognize the decimal. I just want you to do division that you're comfortable with. So 3 goes into 0 0 times. 0 times 3 is 0. We're going to subtract and bring down. And now 3 goes into 7 2 times. 2 times 3 is 6. Subtract, bring down. And now 3 goes into 15 5 times. 5 times 3 is 15. And thank goodness we have no remainder. In a future video, we're going to talk about what happens when you do have a remainder. But for right now, we're just happy we have no remainder. So now I want you to look at this number that we have. We have 0, 2, 5. This could be 25. This could be 2.5. This could be 0.25. I want you to ask the question, does my answer make sense? For example, go back to that real-world situation. If you have 75 cents, and you're dividing it up among 3 of your friends, would it be realistic that each person gets $25? No, that doesn't make sense. Would it be realistic if they got $2.50? No, that wouldn't make sense either, because we're starting off with only 75 cents. How about 25 cents? Yes, that would make sense. Now, we can check our answer by multiplication, by using multiplication. So let's look. Check using multiplication. What we're going to do is think back to your fact families. If it's true that 75 hundredths divided by 3 equals 25 hundredths, then I know that it's true that 25 hundredths times 3 will equal 75 hundredths. You have to think about that relationship between those 3 numbers. So let's check. 5 times 3 is 15. Carry the 1. 2 times 3 is 6. Plus 1 is 7. 0 times 3 is 0. This factor, the decimal goes in twice. This factor, it doesn't go in at all. So we need to move it twice. And sure enough, we get 75 hundredths. Now remember, this is the check portion. The answer to our original problem was 25 hundredths. Now, let's take a look. The student below the students solved the division problem. I should not have put that in. Solved the division problem below using a model, algorithm, and real-world situation. So let's take a look. $2.16 divided by 4. I have $2.16 and share it equally among 4 friends. So even though this doesn't have a number symbol here, we're putting it in it just to make it seem realistic to us. So here's a picture of 2 wholes and 16 hundredths. Let's see. We're going to split it into 4 equal parts. Go ahead and try to do this on your own and pause the video and come back to check your answer. Okay, let's see what you did. Sometimes it's difficult for me to divide numbers that have decimals. So instead what I do is I divide the whole number first, and then I divide whatever decimal is added to it or attached to it. So for example, I took 2 wholes and I separated into 4 equal parts and got 50 or 50 cents. And then I knew I had 16 left over. 16 hundredths left over. Well, if I split them into 4 equal parts, I know that that would be 4 hundredths each. Adding them together, I would get 54 hundredths as my answer. Let's check using multiplication. Oops, actually no, let's do it algorithmically first. 4 goes into 2 0 times. 0 times 4 is 0. Okay, I get the same answer. Now let's double check. Alright, what I'd like you to do now is to try this on your own. Because sometimes numbers can be too large to draw a model for. So you need to solve the problem using an algorithm. Go ahead and solve the problem below. 36 and 4/10 divided by 7. Pause the video and come back to check your work. Alright, let's see what you did. I know that 7 doesn't go into 3. You can put that 0 there if you'd like, but I'm going to say 7 going into 36, and that's 5 times. I'm going to check my answer, and don't be afraid to ask yourself that question. Does my answer make sense? That works out wonderfully, so I know that 5 and 2/10 is the correct answer. Anytime you need some clarification, feel free to play this video back over again. Thank you.